So we're talking about ordered pairs, and I'm going to tell you right now that ordered pairs usually come in the form x comma y. Do they always come in that form? No. And I'm telling you right now, I was tutoring geometry students. You know what form it came for them? Y comma x. Is that okay? It is. And you'll see that it really doesn't matter what variables, but ordered pairs do show a relationship or relationship between x values and y values. So what I'm trying to emphasize here is that these two numbers, they're not just random numbers we just throw out there. X relates to y in a special way. So hopefully you guys have the screen here. Let's look at these ordered pairs. Go ahead and write these down. Guys, I said this is a set of ordered pairs. Do you guys remember what a set is? And if you're like, I don't really remember, you should know something about a set. You want to add something? Okay, that's right.
I remembered what it is, and I said it out loud.
Okay, a set is just describing a certain amount of numbers, a certain set of numbers, which really you're defining it with its own word. What symbol is used first here? What am I trying to draw here? What is this called? A brace, and then a brace to close it out. Do you guys remember set builder? What did your set builder begin and end with? Braces. So we're talking about a set. And then we said of ordered pairs. How many ordered pairs are up here? How many ordered pairs are up here? 1, 2, 3, 4. All right, and then last year, if you were here with me, a set of ordered pairs is called a... You got to know that. You must know that. Because when I refer to relation, you're going to be automatically thinking, Mr. A just said relation. I think a set of ordered pairs. Great. Laura, what's a relation?
Set of ordered pairs.
Good. Mandy, what's a relation?
A set of ordered pairs.
Molly, what's a relation?
Set of ordered pairs.
Sydney, what is a set of ordered pairs called?
Relation.
There you go. Yes. Keeping you on here. That's okay. Thank you for answering correctly. So you got to know back and forth what that definition is. All right. These numbers seem kind of random to me, though, like 3, 6, 4, 8, 5, 10, and 6, 12. But do you guys see that there is a relationship between those?
They're ratio.
Okay, you can think of 3 is half of 6. 6 is double 3. But let's see where it comes from. Who can read on the top of page 94? There's a paragraph. Ira is playing. Braden, go ahead.
Ira's playing a computer game in which he has to swap adjacent pieces of the same colored shape to make groups of 3 or more. Okay. Does that little grid with all those shapes and colors and all that, does that remind you of any games you played? Minecraft. Okay, maybe. But yeah, like Candy Crush I heard from the other class. I used to play Tetris a lot. Used to play against people. You could play like duels of up to 4 people against each other. But after that, guys, I'm not playing these puzzle games mainly because I get too competitive. I get too into it, and then I want to learn secrets, like tricks to get better. No. So we're done with that. But Candy Crush, how many of you played that? Okay, maybe once. How many of you are addicted to it and want to admit it? Good. How many of you are addicted to any other puzzle or mobile game? Uh-oh, okay. Oh, thank you for your openness on that. Okay, but that's what we're talking about. Do you guys know how those games work? You're trying to line up, in this game, what are you trying to line up? 3 or more. So that's what it's saying. Keep going, Braden. If he makes a group of 3, he earns 6 points. A group of 4, 8 points. A group of 5, 10 points. A group of 6, earns 12 points.
You okay?
I'm sorry, Braden's voice just sounds like he has no, just like,
Now, Max, usually when someone says, are you okay? Usually you just kind of say, yes, I'm fine. But you actually gave me a reason why. I commend you for that. But yeah, let's keep going. Finish it up.
How can this relationship between the number of shapes in the group and the number of points earned be represented?
How can they be represented? Yeah, in a relation which is called, or a relation which is, so you give a set of ordered pairs.
Relationship has 2 people in it. And a set of ordered
Right?
Yeah, you can think of it like best friends groups. Usually, I'm not saying always because I know you can have multiple best friends, but usually you have like one friend who's your best friend, usually. And so one person, one best friend. Another person, another best friend. So you can say that relationship. Yeah, relationship has the same idea. Do you guys see that these numbers, therefore, are not random? They're coming from this game. Yeah, from the book. Okay. Now, we're going to look at two concepts with these. Oh.
I remember this.
Now, let me ask this question. How many of you remember domain and range? Like, even if you don't know exactly what it is, at least you heard of those terms. Okay. And some of you haven't been, like Molly, you weren't here last year, so maybe you went through it, maybe not. But this is what domain and range are. And I'm looking at it saying, wait, Mr. A, why is there a giant blank here and a giant blank there? Because we're going to fill it in. Yes, we're going to fill it in just a moment. Okay, I'm going to read these definitions because I changed it from last year. And I want to see if anyone can kind of pick it out. The domain is the set of first elements of the ordered pairs. Do you guys remember what I said last year?
X value.
I said the set of x values of the ordered pairs. Now, does anyone know why I changed it to just the first elements, not x values? Callie?
Because the parts Y from
You can switch them around. You know what? You can also use different variables. R and S, M and N, Q and P. It doesn't matter what the variables are, but the first elements are making up the domain. And then the range is the set of second elements from those ordered pairs. So we're talking about first element, second element, and it could be X and Y, but it can later on be other values. You can think X and Y if you want now, but I'm changing that definition to reflect more accurately what's going on. I don't know if I want to get into this, but I might. Can I give you a little bit of encouragement? I know sometimes when we're doing math concepts, like maybe even today, you maybe you know how to do it, or you figure out how to do it eventually, and then you're kind of like, great, I learned another random fact. But really what you're learning is you're learning the basis of something more complex. So domain and range, if that's all you knew, it wouldn't really help you too much. You're like, okay, I know that. First, second elements. But when I know domain and range, now I can get into harder ideas like geometry and pre-calc, calc, statistics. I get that more. Probability is also there. This by itself means nothing. Just by itself, it doesn't really do anything until you apply it to other disciplines of math. So let me just give you this encouragement. Don't always think that the lesson is contained all by itself. It's part of a bigger picture. And an example of that would be this. When I teach my son how to count 1 to 20, if he just knew 1 through 20, that may help him, may not help him. But why do I want him to know 1 to 20? So eventually he can go 1 to 30, 50, 100, 1,000. And then you're like, well, what's the point of that? Sequence. He needs to understand that there's a sequence of numbers. And then later on when he's your age, he's like, oh, that number line, I wonder what goes after 5 and 100 and 1,000. Wait, oh, you just add another one or add another 10 or add another 100. So he gets sequence, and that's how you build upon things. Just a little encouragement. All right, what are the first elements of those ordered pairs in that previous screen? What are the first elements of those ordered pairs? Yes, Chelsea.
3, 4, 5, 6.
Awesome. 3, 4, 5, 6. That's your domain. In this case, it's just 3, 4, 5, 6. Okay, that's the set of first elements. Now, how do I know we're talking about a set? Braces and squiggly lines like that. My attempt to do a brace too quickly. All right, what's the set of second elements in this ordered pair, relation?
6, 8, 10, 12.
Are you guys able to do that? You can look at ordered pairs and say, I can list out all the first elements of the ordered pairs. I can list out all the second elements. Pretty straightforward. Okay, that's one way to look at a relation. We're going to look at 4 ways. There are 4 ways to show relations, 2 here, 2 on the next screen. So the first way is a rule. A rule? Yeah, like a rule. Yeah, A-R-U-L-E. A rule. No, sorry, it's separate. Yeah, space. A rule. Like rules, regulations. Okay, so what's the rule in this case? I think some of you kind of said it already, but we're going to, you multiply by 2. We would say y equals 2 times x. Seems pretty complicated. Annie, what was one of those ordered pairs? Just give me one of the ordered pairs we had.
3,
3, 6. Okay, that's one of the ordered pairs. Now, the first value in our case is x, second value is y. So here I'm going to put y, I'm going to put x. Is this true or false?
True.
Chelsea knows it's true. Is it true or false? True. So that works. What was another ordered pair? 4 and 8. So 4 goes here, 8 goes here. Is that true or false? True. Think of all the pairs, all 4 pairs. Do they all fit this rule?
Yeah.
If they all fit this rule describes that relation. We say that rule describes that relation. Okay, so that's what we're saying. All right, the table. So it's Emily, what's funny is that I got the same reaction from the other class for some reason.
Oh, wait.
There we go. Now you guys are awake. Oh, got it.
I should get Candy for being the first one to realize what this was.
Yeah, for some reason I'm torn about giving you candy for your response. But anyway, I know, I am too. Okay, what were those ordered pairs again, Jake?
3 and 6.
Keep going.
4 and 8. 5 and 10. And 6 and 12.
All right, now thankfully, you're not really going to make these tables. You're going to be able to look at these tables and get the order pairs from that. So you're not creating these tables. You're using the table to get the order pairs. Now, do you guys see the ordered pairs? 3, 6, 4, 8, 5, 10, 6, 12. Those are the ordered pairs. Pretty straightforward. Nothing too difficult about that. Okay, that's the second way of looking at a relation. The third and fourth ways, mapping and graphs. Mapping. Mapping.
I love that.
We technically call them circle maps, but they're not even circles, so we'll just call them a diagram. Yeah, they're ovals technically. All right, what are the first elements of my ordered pairs or my relation? 3, 4, 5, 6, right? And what were the second elements in my relation? 6, 8, 10, 12. Do you guys notice anything about my order? Yes. Now, let me give you the deep reason why I want the correct order. There are 38 of you in Algebra 1. So this class and the other class combined, right? And Mr. A has to look at 38 domains and ranges. So, oh my goodness. Now, when I think it's 76 sets of numbers on some problems. So what I want you to do to help me out is just put them in order, because then I can look at it very clearly, very quickly to see if you guys are getting it. If you're giving me all in different orders, I have to look at each one and see, all right, are they getting it and I miss one, or it just takes me a long time. So do you want your things graded quickly? No? Yes? Do you want your tests graded quicker? Help me out, please, because I struggle no matter what, but that'll help me out to do it a little bit quicker. Okay, so I got 3 to 6 and then 6 to 12, but on circle mappings, I have to show the relationship. So I have to draw these arrows to show what the relationship is trying to describe. Yes.
We didn't do that.
The mapping?
No, I don't remember that.
I thought I did with 7, but maybe not. And if not, it's okay. It hopefully isn't too difficult. You list the domain, you list the range elements, and then you show the connections.
We did math.
Sorry?
We did math.
All right, I'll let that go. So that's the third way. The fourth way is with a graph, and here I'll do this kind of graph. All right, this is a coordinate plane, and I'm going to emphasize the first quadrant. Now, normally I like going up by ones. Every tick mark's one, but what if I don't have room? You can make it bigger. I don't have enough room. Because I'm going to get into my mapping, which I really don't want to hurt. I can go by twos. You could technically go by threes. When you go by odd numbers, it's kind of hard to know where's, like if this is 3, where's 2 go? Well, it's kind of like right there. So go by even numbers. It's easier to represent. I'm going to go by twos. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. Okay, now it all fits. What was my first ordered pair? 3, 6. So right here. What was in? And guys, this is an exercise in graphing points. That's the very first thing you do when you graph on a coordinate plane. Then you get into lines, shapes, reflections, translations, all that kind of stuff. But if you can't draw a point where it belongs, your whole rest of your graphing life is going to be terrible. Where would 4, 8 go? I start at the origin. Where do I go from there? 4 to the right, and then up to the 8 right here. Okay, so that's the second point. Get the other two. The 5, 10 and the 6, 12.
Won't they all make a straight line?
They should form a straight line. Yep. Oh no.
What?
You guys aren't using graph paper. Welcome to real life, where you don't always get graph paper to graph your points or your lines. Can you graph without graph paper? The answer to that is yes. If Mr. A can do it, which he struggles here, you can do it too with your lines. Okay, so you don't need graph paper. It's nice, but it's not necessary. So I'm looking at these graphs to see if they really are nice or not so nice. Okay, and I'm seeing the same thing on most of your papers now. Bella, did you say they can form a line? Is that what you're saying? Okay, listen carefully. They can form a line, but they don't form a line. Erase that line. Just put the points. I'll show you why. We had 5 was 10, and 6 was 12. So I'm trying to use my words carefully. Could they form a line? Yes. Do they form a line? No. You know why? What are we talking about in this relationship? Do you guys remember what these numbers come from?
A relation.
Sorry? Okay, Ira doing what? He's playing some kind of Candy Crush computer game. Okay, you can do 3 in a row, you get 6 points. 4 gets 8, 5 gets 10, 6 gets 12, right? That's how many points. Is there anything for getting 2.5 in a row? Is there anything for 2.5 in a row? Do they have halves in this game? No. So I wouldn't connect these points with a line because it's not talking about all these values. It's only talking about the ones I already highlighted. And you're like, Mr. A, is that very particular? Yep. Okay, 2.5 and 5 would work for the rule, but in the game, do you get 2.5? No, so we're talking about the game. This represents the game, which is what the whole problem was about. So I'm trying to make it distinct because this is not a line. So as I come by, should I see a line? No, just put the points that could form a line. Okay, I think you guys are good with this. Let's go to the first problem. Number 1 on try these. On page 90, page 95. Try these. Write the domain and range of each relation. How do I want the order to be? Least to greatest. And you're welcome.
Wait, there's 2 numbers.
Mm-hmm.
Oh wait, I'm writing out the whole thing.
All right, looking at number 1, what kind of relation is that? How do they show that relation? Using a table. What are the first elements? That column with the X. Those are your first elements. So line those up, least to greatest. What are the second elements? It's the second column with the Y values. Give me those from least to greatest. And I already said you're welcome. I hope I didn't trick you with that one. Cole, give me the domain least to greatest.
Okay, -6, -4, -2,
0, sorry, last one. Did you guys notice anything about that table? Did they already give it to you in an order?
Yes.
So just take it. Least to greatest. Did they always give it to you in order? No. You need to figure it out after that. All right, what's the range then? If it's Sarah?
-2.5, -1.5, -0.5, 0.5, and 1.5.
Is that in order? Was it given to you in order? Then write it in order, and you're welcome. Okay, and I guess anything I say, you might say, There you go. Okay, take it if it's nice, put it in order. All right, try out number 3. Try these. That's okay. Let me see here. We're trying to get, for number 3.
Wait, I think you
Okay.
don't have numbers? Okay.
All right, do we have, I should ask this, what kind of relation do we have here? How is it described? Remember there are 4 ways. Which way is it? The mapping. Okay, the third one I think was the mapping. Okay, looking at that first bubble, what are the possible domain values? 0. Any others? No. The domain is 0. By the way, guys, do you guys remember last year when you have the same number repeated in the domain or range, do you just keep rewriting it? Or you write it how many times? Once. Okay, that's the domain, 0. What's the range? Yeah, it's just A, B, C. But whoa, Mr. A, I thought the domain and range had to be numbers.
They are numbers.
They are numbers, but do I know what those numbers are? No, they're just unknown, so you just write A, B, C. That's your domain and range. All right. Give me the relation. You may begin. Give me the relation. You're like, what's the relation? Could go back, set of ordered pairs. Wait, ordered pairs? There are no ordered pairs. Yeah, they are. Look at them. They're there. They're just in a different form. So I need to see a brace and then ordered pairs. Oh, yeah. So something like that. What's the first ordered pair, do you think? Yes. Sorry, Elizabeth?
0A.
0A is the first ordered pair. What's the second ordered pair? Sophie? 0B. What's the third ordered pair? 0C. So that's the relation. You guys get what a relation is? What is it?
It's a set of words.
Set of ordered pairs. Callie, what's a set of ordered pairs? Good. Josie, what's a relation? Oh, what's a set of ordered pairs called? Oh, too quick for me. Okay, do you guys get what relation is? Do you get what a set of ordered pairs is? It's the same thing, so please make sure you get that. All right, guys, here's the most difficult concept. Number 2. I need you guys focused. You are almost done. If you get through these next 2 problems, you're gold. You're good for this lesson. But if you don't get this next part, you're going to be sitting here on the homework. Yes, of course you have homework. And I can give it to you sooner than later if you guys are paying attention. All right. What kind of graph is that, by the way, that they give me? What do you call it when it's going like this? Oh, I heard it. Vertical line. All right, so vertical line. Where does it cross the x-axis at? I think it's 2, right? So this is 1. Is it,
No, it's at 2.
Yeah, it is.
yeah, it's at 2. That's okay. All right, we're at 2. Okay. This is actually going to be... I need you to think about last chapter. Do you guys remember set builder? I'm going to do this. Okay. The other class struggled with this, and I totally understand because it's not very easy. Could someone describe this using set builder? It's just a point. So wouldn't it be... Okay, good. X is any number such that...
X is 2. It's equal to 2. It's equal to 2.
It's just equal to 2, right? You guys okay with that? Yeah, so equal. And there's no line going anyway, so it's not an inequality. It's just equal to. Do you guys see that? This is just 2. Just 2. That's your set builder. Okay with that? Okay, now do this next one. And we're not going to call X because we already use X. Let's just use Y. Such that?
Y is any number?
Good. Is any. And we're going to say real number. Any real number.
We have to do all that for the...
Watch. Wait on that. Do you get that?
Yes.
Okay, how many of you get this one? Raise your hand if you get this part.
I got that one.
X is any number such that X is just equal to 2. There's no other value X to be, right? This one might be tough, but if I had a graph where everything's shaded, what can Y be in this case? Y can be anything, right? It can be anything. That's this graph right here. This right here is the graph. The domain, X is any number such that X is equal to 2. And the range is Y is any number such that Y is any real number. And you're like, how is that even possible? Can you guys do this with me? We're going to do an exercise on neck turning and stretching. And it's not too bad. Hopefully you don't hurt yourself. Okay, look at this graph right here. Looking at your x-axis, okay, you guys know what your x-axis is right here? Okay. Where does my line hit the x-axis? At 2 right here, right? How many ordered pairs are represented here? Okay, infinite. Can someone give me an ordered pair up here that is in that line? Just give me any. Okay, 2, 4. Yeah, it's somewhere up here. Okay, give me an ordered pair down here. Okay, 2, -4. Fine, 2, -4. How many are there, by the way? Either way? Infinite. Do you guys notice anything about the first element? What is it always going to be? It's always going to be 2. X is always going to equal... Hey, guys, look at me. Some of you are like zoned out. No, look up here because when you get this on your homework, you're going to be like zoned out there. That's a bad time to be zoned out. What is X always going to be? No matter what point we're talking about here, X is always going to equal 2. Y could be something else. What can Y be? Y is 4. Y is -4. Could Y be? Could it be 5?
Yes.
Could it be 6? So what can Y be?
Any number.
Any real number. That's why I say that. It could be any real number. This right here is the domain and range of that graph up there.
So for any graph, just write like set builder?
Set builder, yep. So are we done with set builder?
I wish.
School wishes too, but no. For just these graphs. Yeah, for these graphs. Let's do another one just to make sure you guys are good. Let's do this one right here.
Not example 2. I'm going to scratch that one out. I'm going to give you a new one. All right, here's my graph. And this line crosses 1, 2, negative 3. This is negative 3. And what kind of graph is this? Horizontal. Good. We call it horizontal. I want you to tell me what the domain and what the range is. So, what can x be?
Any number such that x is any real number.
That's exactly it.
Can you say it again? Normal number though. Like a normal graph. Like what would happen then? Would you still use that builder? Wait, so if it's horizontal, you just switch it?
Yeah, you can think of it that way. Mm-hmm.
Wait, really?
Mm-hmm.
Wait.
So can I give you, let me help you out for some of you who may not be seeing it. Okay, can you give me, what's this point on the graph right here? What's this point? It'd be 0, 0, negative 3. Is that it right here? Okay, can someone give me a point over here? Just any point.
Negative 3.
Negative 3, negative 3. Is that what it'd be down there? Negative 3, negative 3. Give me 1 point over here. 6, like over here. What would y be? What would y be? Okay, look at it here, guys. Stay with me. I'm telling you right now, if you're looking up here, your success rate just went up. Just looking up here. And if you're focused, your success rate is even higher. Because you could be staring at me and have no idea what's going on. But you're looking at me.
Wow.
That's not enough. Okay. What is y always on these points? So what's the range? Y is any number such that y is equal to
Negative 3.
That's it. But what can x be? So look at my x values. It's negative 3 or 0 or 6 or any real number. It could be any real. And you're like, are you sure about that? Okay, ready? This point I'm going to call. Ready? I'm going to call it 3.5 is the x coordinate. 3.5, 3.5. And what would the y coordinate be? It's be negative 3. No matter what your x value is going to be, what's your y value going to be? Negative 3. Yes, ma'am.
So when it's a horizontal line, it's always going to be the range is equal to the number. Okay.
And then vice versa for the vertical. We'll let that go. All right, go ahead. Were you paying attention or not? I'll figure it out very, very quickly. Listen carefully. Numbers 8 and 10. Yes, 8 and 10 are bonus questions. The rest of them are normal. You don't have to do it. If you do it and you get it wrong, it doesn't count against you. If you do it and get it right, you get bonus points. So 8 and 10. So you can circle in your book if you want bonus. Of course. Goodbye, Sybil.